All right, doubling identities. Now, these I won't give to you. I'll give you the sum and difference formulas. You could derive these from the sum and difference formulas. So, for example, sine 2x, we did prove it. If you have a sine of x plus x and work it out, you get 2 sine x cos x. For the double angle for cosine, remember, cosine of a plus or minus b is a cosine of a times the cosine of b minus plus sine a times sine b. So if you replace the a and b with x and x, then guess what? Cos x times cos x minus sine x times sine x. So it's cosine squared x minus sine squared x. That's where it comes from. That's how we get it. So that's why I'll give you this. I'm not going to give you this, right? You got to be able to figure that out. I trust you guys can do it. Now, there's two variations of it, though, two other variations. And it just depends on what you're trying to verify and prove. Sometimes you want to use particular variation because it's just going to make things, or solving an equation, maybe want to use a particular variation. Because if you think about the Pythagorean trig identity, we know what that is. We know it's sine squared plus cosine squared equals 1, right? We know this, right? So what if you replace the sine squared with 1 minus cosine squared? What do you get? 2 cosine squared x minus 1. Or what if you replaced the cosine squared with 1 minus sine squared? What do you get now? Yeah, so there's two variations. There's three forms of it. There's cosine squared x plus sine squared x. There's 2 cosine squared x minus 1, or 1 minus 2 sine squared x. So there's three ways of looking at it. All depends on what you're trying to prove. If it's an identity, which one you should use, or if it's an equation. Like say, for example, I have an equation that has cosine 2x plus sine x. I want to get a quadratic. Then I'd use this one, right? Or what kind of equation I have cosine? Like say like cosine 2x plus cos x equals 0. I got to solve it. I'd probably use this one, right? Because I want to get all the trig functions look the same, so I can treat it like a quadratic function. Because sometimes we do quadratic modeling with this stuff too, right? So anyway, it just depends on what you're given. And then this one here, how do I derive this one? Real easy. Switch colors. Oh. There you go. Tan of a plus or minus b. Again, I'll give this to you. Tan a plus tan b. That's plus minus, but 1 over minus plus tan a times tan b. So replace the x and y. Sorry, replace the a and b with x and y. Add up, you get tan x plus tan x. Down below, you have 1 minus tan x times tan x. What do you got? 2 tan x up top. 1 minus tan squared x down below. That's where it comes from. So these are the summary of these. Yeah, I'm not going to give you these. But you can derive that. If I give you some of the difference formulas, that doesn't derive it. That's the first page. Now we're ready to do some problems, right? Questions? We're okay? Mm-hmm. Good? Awesome. Let's keep moving. All right, so let me tee these up for you guys and then have you guys work them out. So you're going to want to do this. 2 sine x times cos x equals cos x. I'll let you guys carry on from there. Here, which variation should I use of cos 2x? Which one would be wise? With sine? Well, with sine, of course, yeah. So let's do 1 minus 2 sine squared x. And treat it like a quadratic, of course. And you have to find all values. So we'll have to give a general solution. And then down below, I think you're going to do 2 sine x times cos x equals, oh boy. Not terribly obvious which one I should use, but what do you see in the lesson? See sine x and cos x. What version do you have to close to? Probably over the next few steps. What variation do you think would be the best choice? You're co-squared x. You want co-squared x to the other side, right? Yeah, I would do. I like what Catherine said. So yeah, I would do cosine. I would do 2 cosine squared x minus 1 times sine x. Yeah, because then you're going to get things to line up. Actually, they'll cancel, which is kind of nice. So that actually is really nice. That's what I do. So anyway, work these out. Check the answers through table groups. I'll walk around, make sure you guys are doing okay. I'll give you guys the answers, then we'll move on. Okay. Pause recording. There we go. Oh well. Okay. Well, I didn't record all of it, but that's okay. So we're on example 2. We're in Q4 for theta. This is 5. This is 13. This is -12. So cos 2 theta. It's up to you what you want to do. I mean, you can do cosine square sines. I don't really care which one. You can use any variation. Doesn't really matter. But in this case, I'm squaring 5/13. And I'm squaring -12/13. Should have 25 out of 169 minus 144 out of 169. That is going to be -119 over 169. And it should be negative because the angle is somewhere between 270 and 360. Yeah. And then tan 2 theta, we'll switch to red. You're going to do 2 tan theta over 1 minus tan squared theta. Tan theta is -12/5, so we got -24 out of 5, right? Down below, you'll see 1 minus 144 out of 25, which is -119. Flip it, -24 out of 5 times 25 out of -119. 2 negatives. You should get 120. You guys get 120 out of 119? Is that what you guys got for tan 2 theta? Yeah? We're in agreement? Mm-hmm. Okay, cool. All right. Okay, cool. Questions? Okay, we're good? Okay, let's move on to the next one. Okay, again, let me tee these up for you guys. Here's what I would do for these problems when I'm verifying. I would switch this to sine of 2x plus 2x. So even though the right side looks more complex, I'd work the left side because I know what to do there. For b, I would do sine of 2x plus x. You'll have to do another identity within that one. Here, I'd work on the right side. And again, break it apart as 2x plus 2x. I'll walk around and make sure you guys are doing okay. Compare the table groups, see how it's going. After this, then we'll do power reduced formulas. Here, let me just do recording. Okay.
Look at you. There's no way. No.
Actually,
Cosine 2x. Cosine 2x, cosine 2x minus sine 2x sine 4x. Wait, I have it. No, I just put the sign somewhere. I have it because I sine squared x, but it shouldn't be. What the hell? Where did I put the sign? Wait, cosine 2x, cosine 2x.
All right, here we go, guys.
No, I got it.
Wow, his looks so much simpler.
I think part B is mine looks simpler.
Yeah, a lot simpler.
So for part B, it's pretty obvious
I
part
swear to
that's
God,
2x plus x. And sine 2x
looked up
that is. And cos 2x, probably use the cosine squared one to see if cosine squared over here. even though you have three variations of cos 2x, it probably is the 2 cos squared x minus 1 to match that. We distribute my like terms and factor, you're good. C is a doozy. Cos 2x, 2x. So you get cos 2x minus sin 2x, sin 2x. It's not to go that one. I'll go that
I
one.
got it wrong.
Actually, no, there's like sine of no end, sorry, it's the difference formula. After that, I combine this cosine squared 2x and sine squared 2x. Cosine squared 2x, now you did have some variations here. I decided to go with 1 minus 2 sine squared x. Sorry, 1 minus sine squared 2x, and that's sine squared 2x. Those combined. By doing, and if you did it a little differently, I think still would have been fine. I think you could change that one, but I decided to change this one because I have a positive 1 anyway on the left side. So I changed this by using a pattern trigger at the end, make it 1 minus sine squared 2x. Combine these two to get negative 2 sine squared 2x. Then this part you have to be really careful. That's sine 2x times sine 2x. That's 2 sine x cos x, 2 sine x cos x. That becomes 8 sine squared cosine squared x. That's verified. I know, it's pretty crazy. That's it. That's a nutty one. Yeah, for sure.
You did?
You did?
I did the right side. I just started.
I think I got it.
You did like many times.
Yeah. Exactly. If you just like change that.
Alright.
Wait,
Which I did not do.
Yeah, okay. All right. What time do we get out, by the way? Okay, so we should probably start the homework quiz then. Yeah, let me go and clear my screen. So we'll pick up the rest of these notes on Friday, and yeah, right, 1:35. And then looking at the rest of the notes here, I mean, the power reducing formula is kind of discussed in the next section anyway. Actually, that's repeated. What? Hold on, part 4. Oh, that's weird. Wait 1 sec. Oh, those are algebraic. Okay, got it. But I feel like some of these are repeated. Okay, anyway, you know what? We'll be able to finish off notes anyway just fine. I think there's a lot of repetition in part 4. We'll be able to blast through this just fine. So, and then the homework is not going to have, I'm not going to do half angle with you guys in the homework because we didn't talk about that today. Yeah, there's no half angle here. So we should be fine. So homework you guys should be okay with. Yeah. And I think I already posted what I wanted you guys to do in the homework anyway. Yeah, I think I said 1 through 9. Let me double check. Yeah, homework number 15. Let me just make sure I didn't mess that up. Oh, I need to post it. Yeah, so we'll definitely do look at the homework again. No. Yeah, so this homework here, this homework 15 handout, you guys should be able to handle all the problems because there's no half angles here. Yeah. Wait, oh no, you can't because it's a power reducing one. Shoot. Okay, so I'll have to have you guys skip some of these. That's okay. I'll figure it out. Okay, I know, right? So I'll put up the homework just a little bit. Let's do the homework quiz. Let me stop the recording.